Hello, a Rosie math teacher coming at you from my 4th period accelerated grade 7 math class, where today we are working on items 17 through 24, I think it is, on today's homework review. A bag contains a total of 12 marbles. Y'all start to sketch a scene right now. Draw yourself a quick little bag of marbles. Mine looks like a tulip bag somehow. Okay, how many marbles are in the bag? 12. Please write 12M representing 12 total marbles. And 4 of those marbles are blue. Please draw an arrow coming out of the bag and label that 4B for blue. If a marble is randomly selected, return to the bag. So a marble is pulled from the bag. It is then returned. A second marble is then randomly selected, pulled from the bag. It is then returned. The theoretical probability that the first marble is white and that the second marble is blue equals 7/36 probability. How many white marbles are in the bag? Now, the reason I am zeroing in on my W and my B and my equals 7/36, I would like to know if my class remembers that if we do something on the first pull of a marble and we write down the ratio or the theoretical probability of pulling that marble, and then we write down the theoretical probability of pulling a blue marble, what is it that we do in between those two probabilities? Is it add, subtract, multiply, or divide? Please answer now. Oh, okay. Let's go back. Let's go back to when we first started doing probability. I will refresh your memories. When we flipped a coin, for example, what were the chances? Let's say we were flipping a coin 2 times in a row, just like in this situation, you're pulling a marble from a bag 2 times in a row. If we flipped let's make it a quarter, and we want to see how many times it would land on heads first, and then on the second try, land on tails, right? So when we thought about that, what was the probability, the theoretical probability that when I flip a coin 1 time, it will land on heads? Say that probability. 1/2. What is the probability when I flip the coin the second time that it will land on tails?
1/2.
1/2. 1 out of 2 each time. Does anyone remember what we always drew in between these two ratios to find our total theoretical probability of first flipping a heads and then a tails? What did we put? Add, subtract, multiply, or divide?
Multiple.
I'm glad I hear a few people saying it. Oh, wow. Okay. It's a good thing we are reviewing, guys. It's okay. We got this. All right. Guys, you multiply. Always take the probability of the first scenario, multiply it by the probability of the second scenario, and you will get the overall probability of those 2 scenarios happening one after the other. Is this at least reminding you? We are glad we're being reminded. Okay, so now let's look back. Now that you realize I am taking my white probability and doing what by the blue probability? Okay, I just told you guys. Okay, so now we know. Multiply. Thank you. I needed to hear your voices. Guys, do we know the probability ratio for the marble being a white marble? No, correct, we don't. So draw yourself a box where that ratio will go, because we do need to figure it out. And then copy your multiplication sign, and then write yourself a ratio for the amount of chance that it will be a blue marble. Where do I find my numerator piece if the situation says a bag contains a total of 12 marbles and 4 of the marbles are blue? Oh, remember, that's why we sketched the scene. 12 marbles in all, 4 of which are blue. So I'm hopeful that the majority of my class's time, when I get on the count of 3, can you tell me number out of number? Only don't say the word number. Hopefully you're reading my mind. The probability of getting a blue marble out of that bag. 1, 2, 3.
4.
Yay! Most of you said it. 4 out of 12. Everybody, please write that now. Do we agree that we have unknown factor multiplied by a known factor equaling a known total probability of what? Say that. 7 over 36. I hope you guys are writing down notes, copying the things that I am writing up here because it will help you out there. Now let me ask you this. Way back in your math education, did some teacher somewhere along the way teach you how multiplication and division are inverse operations of each other? Did you ever do something called fact families? Where you might say 2 times 3 equals 6, 3 times 2 equals 6, 6 divided by 2 equals 3, 6 divided by 3 equals 2. Anybody do that? I always did that with my students, 3rd through 5th grade, because the more you chanted those fact families, the more you understood how multiplication and division are interrelated but inversely so, in an opposite direction, right? So ask yourself this. If you cannot figure out what to do with these numbers to get this number, ask yourself, what if it said blank times 3 equals 6? What number do we know goes in that blank? 2. What can we do with the number 6 and the number 3 that would give us that missing 2? Divide. And I like that someone said the order. Which number would we put in a calculator first? The 6. So what do you think you're going to do with the amounts 4/12 and 7/36? You're going to what those numbers? Divide. And which number will go in your white calculator first? The 7 over 36. Pick up your white calculator right now, and I will show people online how this calculator can do fractions, y'all. You should love it. So you're going to tap 7, the fraction key, we call it the ABC key. And then what are you tapping next, class? 36. And then we are tapping what key? Divide by. And then we are tapping what for the 4/12? 4. What key next? ABC. What keys next? 1, 2 to make 12. Then tap equals. What does your calculator say? Aha. So what is our missing factor? 7 over 12. Now, do you think 7/12 is the final answer? Can you have 7/12 of a white marble? No. But since we know it's 7 out of 12, say no more. Write down the answer that you know you will be writing inside that space when you open your computers in a moment. Now let's go to item number 18. This time we're dealing with a deck of cards containing 6 cards with a circle, 9 cards with a square, 3 cards with a triangle, and 7 cards with a trapezoid. A card is randomly selected and returned to the deck. So we've got all these cards in our hands, right? How many shapes are available on these cards? Somebody count them for me. Okay, how many shapes? Name the shapes. What's the first shape?
Circle.
Good. The second one?
Square.
Third?
Triangle.
Last?
Trapezoid.
How many different shapes are available? Not how many cards. How many different shapes are available? Say it. 4. Now remember, long ago, we learned that our base number will always be the possible options. What are the number of possible options of shapes? 4. So write a giant 4 as your base. I should see everybody writing a giant 4. Maybe they've already written it. Maybe they read my mind. I don't know. Okay, a giant 4 as your base number. Does anyone remember where we always got our exponent when we are trying to find the theoretical probability for how many outcomes are in the sample space for the different ways cards can be chosen? Now remember, to be fair, let me finish this part of the task. A card is randomly selected and returned to the deck, and then a second card is randomly selected. So you randomly select a card. It could be either a circle, a square, a triangle, or a trapezoid. There are 4 different shapes it could be. That is how we got our what? Base. We pull a card out, we put it back in. We pull a card out, we put it back in. How many times did we do that? How many times did we pull out a card and put it back in for a single turn? 2. Write that as your exponent. I'm not going to write it on the screen because I want to see you doing the words that I am saying. Your exponent comes from the number of tries. The number of tries. And then you will do the math with your 4 to the what power? To the second power, and you will get your correct number. Go to item number 19, looking at my screen. What value of x satisfies the equation 2.5 x plus 4 equals negative 18 plus x? Guys, I'm super hopeful that you remember we need to do something with the associative property happening inside my red box. Yes? Yes. What is the first thing we're going to do? Say it. Multiply 2.5 times x. What will you get? Good. Write that down. Multiply 2.5 times 4. What will you get? 2.5 times 4. You do have calculators. It does equal 10. Okay, 2.5 times 4 equals 10. So you just wrote what? Plus 10. I'll go ahead and write it. It will probably help for those watching. 2.5x plus 10. Any questions on how we got 2.5x plus 10? Okay? Equals. Now, here's where some students are having a little bit of difficulty today. They're not sure how to handle this distributive property problem. This is also distributive property. It's just missing a number. What number could I put next to the negative sign? 1. Oh, I love it. And then I multiply what?
Negative 1 times 18.
And what does that equal?
Negative 18.
Everybody write that down in your notes right now. And then I multiply negative 1 times what?
X.
What will that equal?
Negative X.
Negative x. For now, I'll let you go ahead and keep the 1 because you're going to want it in a moment. Negative 1x. Hold on.
Eighth grade students.
Okay, that's not for us.
Be sure when you go to lunch that you bring your permission slip and your money to buy the tickets for the dance.
8th grade dance. Y'all behave yourselves next year so you get to go to it. Okay, moving on. 2.5x plus 10 equals negative 18 minus 1x. Does anyone remember what you need to do next? The very next step. I need to move something. What do I need to move? Say it. I need to move the x. Very good. So what will I do with the negative 1x? Because remember, you cannot keep x's on both sides of the equal sign.
Combine like terms.
No, I am not combining. Oh, okay. Okay, everybody listen to me. You will only combine like terms when the x values are on the same side of the equal sign. When there are different x values on opposite sides of the equal sign, if you combine those, you're going to be wrong. You have got to look at your two x values. As much as possible, pick the x value that is worth less. Class, what is worth less? Negative 1x is definitely worth less than 2.5x. So do the inverse operation of negative 1x. What is that? Plus 1x. Do that on both sides. Write it on your papers now. Plus 1x. Where do I write the 1? Underneath the 2 or underneath the 0.5? Underneath the 2, because it's a whole 1. What do I get when I add 2.5x plus 1x? Excellent. 3.5x. Copy your plus 10, equaling what amount? Negative 18. Guys, when you get to that in a moment, don't forget you undo the constant first on both sides. Then you undo your coefficient on both sides. You will get your value for x. Moving on to item number 20. This one won't take long to talk about. Listen carefully. If Americans in the United States, each person generates or causes about 1,790 pounds of trash per year. Whew, that's a lot of trash, isn't it? Yes. The population of the United States is about, write this down, 3.3 times 10 to the 8th in the United States. About how much trash does the entire population of the United States generate per year? Well, guys, what was the 1,790 pounds? That was per what?
Person.
Per person. And then they told us that 3.3 times 10 to the 8th was the total what? Population. What does it mean? If this is the number of our population, then how many people is it? It is that number of people. Guys, do you realize the word population simply means that many people? Okay? So that many people are using this much or creating this much pounds of trash per person per year. Do you follow? So if I know it's this number per person and I know it is this number of people, what should I do to find the total amount of trash? Your answer in a moment when I count is going to either be add, subtract, multiply, or divide. Ready? 1, 2, 3. Okay, so I see we need to talk about this just a little bit more. All right, so draw yourself a little person. Draw yourself a little person. And show that person saying, I trashed 1,790 pounds. I trashed 1,790 pounds. Hopefully you didn't leave that on the street. You put that where it belonged. Okay, I trashed 1,790 pounds. Now, according to the data, this is per what? Per person. It is per year also, but the whole thing has to do per year, so you can let go of that. It's per person. So, if there were 2 people, if you drew a second person, right, would they be saying the same amount? Would they be saying the same amount?
Yes.
Yes. So what could I do with that number of pounds to figure out how much it would be for 2 people? I could what? Excellent. So if I only wanted to know the total trash for 2 people, I would do 1,790 pounds times 2. But wait, what if I want to know how many pounds of trash it is for 3 people all saying the same thing? Then I would do 1,790 times 3. So in the problem that we are looking at, we were told it's this many people. So now that you realize I want to take the number of pounds per person and multiply by number of people, what do you think we're going to do with the number of pounds and the number of people? We're going to multiply. Everybody put a multiplication symbol there. In a moment, when you come back to this item, use your online calculator. Literally copy that number times, copy it written this way, and you will get your correct answer. You just needed to figure out to multiply it. Do you see now how to do that next time? I always hope. All right, on this next one, this one's pretty tricky, and I need everybody following along. Please recopy for item number 21. Y equals -4 over 3x plus 3. Everybody copy that immediately. Everybody copy that immediately. Guys, whenever we are trying to find a way to graph a situation, the smartest thing for you to graph first is the original plotted point that your line began with. If this were a y equals kx value, where would your first plotted point go? At the point of origin labeled what? 0,
0,
comma.
0.
I got like 30 kids in this room. They're all sleepy after lunch apparently. Okay, guys, if this only said y equals 4/3 x, I want you to see that for just a moment. You don't have to change yours. But this would be in y equals kx equation form, wouldn't it? Whenever you see a y equals kx, what does k represent? Your constant of proportionality. If you drew a line on a graph for something that is proportional, where would it always have to begin? At the point of origin, always located at what? 0, 0. So guys, if they only gave you this, right? Then you would put your first plotted point at 0, 0, because you would know this is a constant of proportionality. And if your formula contains a constant of proportionality, it is therefore proportional. Yes? So your first plotted point would go at 0, 0. Then you would decide on the value of x, multiply by -4 over 3 to get your value of y, and that would be your second ordered pair. However, for this item, they do have a different form of an equation. It is in the form of y equals what? mx plus b. And did I copy correctly? It was plus 3, yes? Okay, who remembers what b always represents? It's called the y-intercept. So where will your first plotted point go? If your y-intercept is a positive 3, then on your grid, if this were labeled 0, 0 right here, then how many spaces across would you go? 0, because I'm going to put it on the y-intercept, yes? And how many spaces up would you go? 3. So in a moment online, your first plotted point, if this is 1, 2, 3, your first plotted point would go here. Do you understand why? Remember, your y-intercept is your one-time fee or your one-time amount. What is your one-time amount in this equation? 3. It's always in the y-intercept location, and you would always put your beginning plotted point with your little, remember how they give you an arrow with 2 plotted points and then there's an arrow? Grab one of your plotted points, put it right there. Do you follow why that one goes there? Okay, now for the harder part. Whenever your coefficient in front of the x is a fraction, you have got to use either the numerator or denominator in place of x. Name which one you think you should use. You should use the denominator. So class, right now on your paper, either erase and replace x with a 3 or rewrite it underneath, your choice. But make sure you are multiplying by 3 in place of that x. Please write it now. It helps your brain to write it. If you need to rewrite the equation, that's fine. Then on your calculator that you have in your hand, what are you going to multiply to find your value of y? Read it to me. And actually, you know what? I think I'm going to let you wait and do this in the online calculator. What will you put in the online calculator? -4/3 times 3 plus 3. And then you will find your second ordered pair. Again, what would the second ordered pair begin with? Okay, guys, the first plotted point was 0, 3. Sorry I said again, because we didn't talk about this one yet. Your second plotted point also needs the x, y value. Name the x value you plugged in here. 3. So can we agree you have to use 3 for this x value? And then once you have plugged all of this in your online calculator, will it give you the value of y? Yes. And you will put that number right here next to the 3. You will plot both of these points and you'll be done. And it will be a beautiful thing. All right, let's go to one more item and then I'm letting you guys begin. Which of the following expressions are equivalent to, guys, you need to practice this, x over 3 divided by y to the -2, I shouldn't have said x over 3, it was x to the 3rd power, over top of y to the -2 power, and both of those raised to the -4th power. So here's what you want to do right away. You want to simplify this and then see how many ways it could be written to equal any of the options they give you down below. I'm going to show you a few ways. First of all, let's do this. Let's keep everything in the position it's in for the moment. X to the 3rd times the -4th will give me what? New numerator. X to the, what's 3 times -4, y'all? -12. Great, thank you. Some people woke up. Yay! And then y to the -2 to the -4. I'm going to write y to the what? What's -2 times -4? 8. Excellent. Now, you're likely not going to see it written this way. Remember that typically, when we have a negative exponent, we like to flip it to the other section, to the opposite section, and take away the negative. So if I did that with x to the -12, what would happen to it when I flip it down below? Does it keep the negative symbol or drop it? It drops it. So it would become, wait for it, it would become x to the 12th, y to the 8th. Do you see why? I didn't change the y to the 8th. It stayed the denominator, didn't it? Yes? But the x to the negative 12, I flipped it to the opposite position, which the negative sign tells me I can do. And then when I remove it to the new position, I remove the negative sign. What do I put for the numerator when I have nothing left in the numerator? I have 1. Good. One person told me. Thank you, one person. Okay, so this is a possible option. If you see that anywhere later when you are looking, you might want to write this down. All right, and then by the same rule, if I decide I would rather have my x and y values up above. So if I decide I want to flip the x to the 12 back to the top, what does it become? X to the negative 12. Sorry, I can write 12, not just 2. X to the negative 12. And then if I flip, so I already flipped the x to the 12 to the top. What if I flip the y to the 8th to the top? It becomes y to the negative 8. Now, do I need to put a 1 in the denominator space, yes or no? I don't need to, because anything over 1 is that thing, right? I drew it just so you would remember. When we do 4 times a fraction on paper, you put 4 over 1, don't you? But if your answer is 4 over 1, do you keep the over 1? No. So don't keep this over 1 either. And what does it mean when 2 variables are written beside each other? They are being what? Multiplied. All right, I think that was all I need. Yes, that was all I needed to talk about. I hope this helps you guys. Get busy right now. Do the very best you can. Let me know.